Okay, guys, we are on to volume. So we have to kind of, even though we're still dealing with three-dimensional shapes like we were with surface area, we have to reset our minds when we're looking at ask for volume, because volume is asking about a different thing. When we talk about surface area is just, hey, what is the area on the outside of a shape? That's all that they care about. Has nothing to do with the interior. It is only the area of the outside faces. When we talk about volume, volume isn't anything on the outside. It is actually taking into account how many cubic units we can fit on the interior of a shape or the inside of the shape. So how many of these little blocks of my cubic units will fit? Okay, and so we say that volume is measured in cubic units. Now, one way to think about this is so if we needed, for instance, if we want to say inches cubed. Well, inches cubed, think of 3 as being 3 dimensions, right? We want to know how many 3-dimensional blocks will be on there. Whereas when we did surface area, we did inches squared. Well, that was just 2-dimensional. And way back when we just did length, that was just 1-dimensional, right? That was to the first power, the second power, the third power. So if you're doing volume, that's how you can keep the correct units in your mind. Now, volume is relatively simple if you have a certain amount of information. Here's the idea of volume. If I want to know the volume of any prism, I'll take the area of the base. Now, keep in mind, that base is a capital B, meaning it is the area of the polygon, not just one length, because sometimes we'll do, well, triangle's 1/2 times base times height. Well, we have a base that's the base of the triangle, but we also have now base, which is an entire face, an entire polygon. So we have to keep that straight in our minds. And all we have to do is, for volume though, is just take the area of that base and multiply it by how tall the prism is, okay? And so the formula here is just capital B times capital H. Again, we have different heights, different things we have to think about, and so we got to keep that straight in our minds. Now, the easiest one to do, and I'm sure you guys even did this probably way back in grade school, is to find the area of a rectangular prism. So the area of a rectangular prism is pretty easy. The base here is a rectangle. So base is a rectangle, which is 24 times 20. And the height of that prism is 10. So when I do 24 times 20, that's going to be 480. And so the volume is going to be 480 times 10. And so it'll be 4,800. Remember, these are cubic units now, so it's centimeters cubed. Now, I hope you're still watching this video, because a lot of guys will watch this and assume that they know exactly what's going on. And so a lot of guys are going to do is they're going to look at this next one, and they're going to say, oh, 5 times 6, that's 30, and the height is 10, so it's 300. Guys, the answer is not 300. That is not the answer here. You would get it wrong, because the base is not 6 times 5. Remember, the base of a prism are the two sides that are the same shape, right? So the two parallel faces. So in this case, the base of the prism is a triangle. It's 1/2 times 6 times 10, right? 10 is not the height of the prism. 10 is the height of the triangle. So we would get 3 times 10, and so that is 30. So that is the area of the triangular base. The height then, and this is a little weird to think about because the way the shape is oriented, but the height is 5. Remember, the height of a prism is the distance between the two parallel faces. So what's the distance between the two triangles? 5. That is the height of the prism. Even though it's on, quote unquote, the ground, it doesn't matter how the shape is oriented. Height, when you deal with prisms, is the distance between the two parallel sides. So now when I go to do volume, volume is going to equal the area of the base times the height of the prism, And so it's going to be 150 cubic meters. A lot of guys, I'm telling you, a lot of guys are going to look at that and say, oh, 5 times 6 times 10, and they're going to be wrong because they're not thinking about what the polygon is that creates a base. What kind of prism is it? So it is important when you look at this to figure out what type of prism it is. We move on to look at the volume of a cylinder. What's nice about a cylinder is it's just going to give you a standard, straightforward formula, right? So just like a prism, the volume is going to be the area of the base times the height. Well, the base is a circle, right? The base of a cylinder is always a circle. And so a circle is always pi r squared, right? When we have different prisms, it could be any polygon. It could be a trapezoid. It could be a triangle. It could be any polygon. And so we can't really set one formula out as the answer for that. But when you're dealing with a cylinder, the base is always a circle. So it's always going to be pi r squared and then times height. So the volume of the cylinder is pi r squared h. Now, let's look at this next cylinder that we have here, this example. They give me that the radius is 3, so it'll be 3 squared. The height is 8, and so 3 squared is 9. 9 times 8 is 72. So the answer here is going to be 72 times pi. Remember, we have cubic units here, so it'll be centimeters cubed. Okay, guys, for our last example, we're going to have to do a combination of the two, right? So if we look at the shape that's drawn here, this fish tank that's full of water, we want to figure out the volume of that. That's not a prism and it's not a cylinder. What it actually is a combination of the two. So if you can imagine me kind of drawing this in here, what you would see here is we would have a prism on the left and a cylinder, not even a whole cylinder, but actually a half of a cylinder on the right. So we have a prism and a cylinder. And what you'll also notice is some of these dimensions are a little off. So let's look at the dimensions as they're drawn. Well, if this is 24 inches, then that would mean this entire width here is 24 inches. And since that's a cylinder, the radius would be 12 inches. So the radius here is going to be 12 inches. And that also affects this measurement down here because the prism stops at that corner. The prism doesn't continue all the way out. And so the question then would be, well, what is this length here? Well, if the radius is 12 inches and this entire length is 48, we'll just subtract 12 from 48. So 48 minus 12 leaves us with a prism whose length there is 36 inches. Okay, so now we can put this in terms of our formula, and I'm going to show you a very nice way of writing this out so that everything is kind of clean and organized, because we got a lot of bases, a lot of heights, a lot of things to look at. So the way that I write this out is I literally say here, the total volume equals the volume of the prism plus the volume of half of the cylinder. And so I can write my formulas out. Well, what's the volume of the prism? Well, it's going to be the area of the base times the height of the prism plus half of a cylinder, so I'll put 1/2 pi r squared h. Well, what's the area of this base? The area of that base is going to be 36 times 24. What is the height? The height is also 24. What is the radius? Remember, we figured out the radius over there was 12 inches. Not 24 inches, but 12 inches. 24 would be the diameter. And the height of the cylinder, well, it's the same as the rest of the tank. That is also 24. At this point, I can start to put some of this in my calculator. So I went ahead and put that in my calculator, guys, and wrote that out. 36 times 24 times 24 got me 20,736. When I worked out the math for the cylinder, that was 1,728 times pi. And if you wanted your answer perfectly, you could just put this in parentheses and put cubic inches and you'd be done. But I decided to multiply that all the way out, and when I multiplied that all the way out, I got to 26,164.67 cubic inches. And now there's lots of different questions they could ask you on an ACT or SAT from that. They could say, okay, if water weighs X amount of pounds per cubic inch, how heavy will this tank be? Or if a gallon is this many cubic inches, how many gallons will it take to fill the tank? So there could be some conversions that they could throw onto this to make you think about, other stuff that goes along with this. If we were in class, we would probably log on and figure out, how many cubic inches are in a gallon and divide it by that number and see how many gallons fit in that tank. But we'll leave that alone for now since we're doing things remote. Check out the homework upload to Schoology. Contact me if you need any help, and have a great day.